Hello, my name is Axel Scherer. I will give you a quick introduction into interface UVC environments. So basically the environment is the top level of the interface UVC. This is where all the subcomponents are instantiated and configured. Right? For example, you can tell it, hey, I need so many agents. Those type of agents are XTX, master slave, whether to have a monitor collector right here or locally. You can establish all the connections and things like this. So basically, it's a container module or container class that has all its subcomponents and configures them for your particular application of this interface UVC. Let's look at a particular example. Here we have a hardware system with 2 masters and 3 slaves. Okay, so for UVM to be flexible, you need to be able to adapt your interface UVC to whatever configuration you have, right? So maybe you need 2 master agents and 3 slaves agent. Maybe some of them have to be passive, some active, and so forth. This also allows you, if you have an incomplete system or you want to test a particular aspects, to replace an existing hardware system with an UVC, like here, to give you more controllability. Maybe you even narrow it down a lot and you have full or more control to test a particular corner case scenario. So in the end, the interface UVC needs to be very flexible to adapt to any need you have for a particular interface and any particular test application. So the interface UVC is basically, the interface UVC environment basically looks like this. It's this container, and then you can say, hey, I need 2 masters and 3 slaves in this particular case. Okay, what you don't see here, it could also be configuring active and passive and things like this and other aspects. As we have a shared bus system here, we can, for example, have a common monitor collector pair, right? So you don't have to have redundancies. Depends on your particular interface UVC and how you want to structure things. Let's look at some example for this. We have an APB system that has basically implies we only have a single master, but we can have multiple slaves. And you can see the topology right here, right? So we have one instance of the interface UVC for APB. It has a shared collector monitor pair, has 1 master and 2 slaves. Okay, so let's look at the code for this environment. Scroll down. You can see the interface top layer is derived from UVM env, so that's an environment class. It has the virtual interface here to connect to the RTL device. And then here are all the subcomponents, right? We have the bus monitor, the collector, 1 master, and an array of slaves. So this allows us to adjust this particular APB UVC to as many slaves that you have in your particular application. Okay, let's scroll down. There's some regular plumbing. How is this being created? We always create, no matter if we are passive or active, a bus monitor and collector. Okay, and we're also creating a master here. On the slave side, we are dynamically allocating how many slaves we need, right? So we have a loop here that creates only the slaves that are required for this particular application. And later on, we're connecting the ports in this device. For example, here the bus collector is talking to the bus monitor, right? So there's this connection established and so forth, right? So that's basically it. The UVM environment in an interface UVC allows you to configure your particular interface UVC to whatever application you have in mind. You can find more videos like this either on this YouTube channel or at support.cadence.com on the video library for the Incisive Simulator. Thank you very much, have a great day, and talk to you soon.